Graph the equation and label relevant points. If the graph is a hyperbola, show the fundamental rectangle with its corner points labeled, the asymptotes, and the intercepts. We're given the equation x squared over 49 minus y squared over 25 equals 1, and this is a hyperbola, and of the two mentioned, this is the one where we have x-intercepts and not y-intercepts. So I want you to compare this equation to x squared over a squared minus y squared over b squared equals 1. And if our equation of a hyperbola can be written in this form, because it's equal to 1, we have a center at 0, 0, and we have x-intercepts because our x squared over a squared term is first. This hyperbola will have x-intercepts and not y-intercepts. Some other values of interest: if a squared is equal to 49, that implies that a is equal to plus or minus 7, and also b is equal to plus or minus 5. And this will help us determine the fundamental rectangle, intercepts, etc. So our two x-intercepts occur at positive 7, 0 and negative 7, 0. So label those 2 points. Here we have positive 7, 0, and out here we have negative 7, 0. So our hyperbola will pass through those 2 points. Now, to determine the fundamental rectangle, we simply form all 4 of these corner points using our plus and minus a values. So let's label the points positive 7, positive 5, positive 7, positive 5, 7, 5. We have the point negative 7, positive 5, negative 7, positive 5. And then we have negative 7, negative 5. And finally we have positive 7, negative 5. Positive 7, negative 5. And I obtained those 4 corner points by using the plus and minus a values. A is being the x-coordinate and b being the y-coordinate. And now we can connect those 4 points with a rectangle, and that is what our fundamental rectangle will be. So let's draw that rectangle in. So there's our fundamental rectangle. And now if we connect the corners of our fundamental rectangle with a diagonal, we now have the asymptotes that our hyperbola must abide by. Oops. Like that. And now we simply pencil in where this hyperbola will lie. It must go through the x-intercepts that we've determined and then get close to these asymptotes, but never touch. So in red here, I'll try to draw in a hyperbola. So hit that point and then get close, never touch. And likewise on the right hand side, hyperbola will come down, touch that point, get close, and never touch. So there is our graph.